Hey everyone, so today we are going to talk about something that confuses a lot of people in statistics, p-values. Don't worry if you have struggled with this concept before. We are going to break it down in a way that will finally make sense. Let's start with something that we all know, flipping a coin. Imagine you are playing with a coin, but you start to suspect it might be unfair. So you decide to test it. You flip it 100 times and you get 60 heads. Now here's the question. Does this mean the coin is definitely unfair? Or could this happen just by chance with a fair coin? This is exactly where p-values come in handy. Think of a p-value as measuring how surprised we should be by our results if everything was normal. In our coin example, it tells us if this coin were completely fair, what are the chances we would see 60 or more heads out of 100 flips? Mathematically, it means what is the probability of getting 60 or more heads given your coin is fair. When we do the math, we get about 2.8%. This means if the coin were truly fair, we would see results like this or more extreme only about 3 times out of 100 experiments. Scientists often use 5% or 0.05 as their cutoff point. If the p-values is less than 5%, they call the results statistically significant. In our case, 2.8% is less than 5%, so this would be considered statistically significant. Think of it like this. If something would happen only 3% of the time by chance, we might start to suspect something else is going on. Now here's where people often get confused. A p-value of 2.8% does not mean there is a 2.8% chance the coin is fair. There is a 97.2% chance the coin is unfair. The bias in the coin is 2.8%. It only tells us how surprising our results would be if the coin were fair. Here is something fascinating. Let's say we have a coin that's just slightly unfair. It gives heads 51% of the time instead of 50%. Watch what happens with different numbers of flips. 10 flips, not significant. 100 flips, not significant. 1000 flips, significant. 10,000 flips, extremely significant. This shows us something really important. With enough data, even tiny differences become statistically significant. But this brings us to our next point. Just because something is statistically significant does not mean it's practically important. If we flip a coin 10,000 times and find it gives 51% heads instead of 50%, that might be statistically significant. But would you really care about such a small bias? When you are looking at p-values, always ask yourself, how big is the effect we found? Does this difference matter in practice? Could other factors be influencing our results? Remember, p-values are tools that help us make decisions, but they are not magic numbers that gives us absolute answers. They tell us how surprising our results would be if nothing interesting was happening. The next time you see a p-value, ask yourself, if everything were normal, how surprised should I be by these results? That's really what p-values are all about. Thanks for watching. If you found this helpful, don't forget to like and subscribe for more videos like this. I will see you in the next video. Take care. Bye.